Here we have a problem that reads, do you expect the diffusion coefficient for a particle through hot water to be larger than, smaller than, or about the same as its diffusion coefficient through cold water? It would benefit to have some sort of outside knowledge here, some sort of outside knowledge in the form of the ideal gas law, which is P, V, N, R, D. And it also will be beneficial to have our equation for our diffusion coefficient, which is D equals 1/2 d squared over our change in t. This chapter, of course, talks about proportionality, and so we can determine some relationships here to explain why our diffusion coefficient may be larger, smaller, or the same depending on the temperature of the water. If we look at the ideal gas law, we have pressure, we have volume, we have the amount of the substance, which is what N is going to stand for. We have our constant, our ideal gas constant, which is R, and then we have the temperature. And so immediately from here we can say that pressure is proportional to temperature. So as pressure goes up, temperature goes up. As pressure goes down, temperature goes down. And so if we think about it, and we think about this concept in terms of our diffusion coefficient, we can say that our pressure is proportional to the distance that the molecules travel. We can also say that if our temperature is proportional to our pressure, and our pressure is proportional to the distance that the molecules travel, we can say that our temperature is proportional to the distance that the molecules travel. And then we can apply this to our actual problem, which we can say that the temperature of hot water is greater than the temperature of cold water. And if temperature is proportional to pressure, we can say that the pressure of hot water is greater than that of cold water. And we can also say that the distance of that the molecules travel in hot water is greater than that of cold water. And then we can take this knowledge and apply it to our diffusion coefficient. So if the diffusion coefficient for hot water equals 1/2 d of hot water squared over change in time, and the diffusion coefficient for cold water equals 1/2 the distance the molecules travel in cold water squared over a change in time, then we can compare these two diffusion coefficients. So the diffusion coefficient of hot water compared to the diffusion coefficient of cold water, and we can say that 1/2 dH squared over change in time, compare it to dFc squared over change in time. And we see that our 1/2s cancel out, the change in time cancels out, and we're just left with dH squared over dC, or compared to dC squared. And we already know that dH is greater than dC. So we can say that our diffusion coefficient for hot water is greater than our diffusion coefficient for cold water.